Now let us look at the next problem. This problem is based on two statements 1 and 2. After reading these statements 1 and 2, we have to choose the correct option. Now let us see what the first statement has to say. Energy is released when heavy nuclei undergo fission or light nuclei undergo fusion. Okay. Now this is true. If a heavy nuclei it disintegrates or there is a fission, then since the binding energy per nucleon in the case of heavy nuclei was lesser, because of which it underwent disintegration to another stable nuclei having more binding energy per nucleon. Therefore, energy is released. Okay. Similarly, a lighter nuclei goes for fusion because binding energy per nucleon for lighter nuclei is also less, and when it undergoes fusion, the relatively heavy nuclei formed out of two lighter nuclei is more stable. That is why energy is again released. So whether it is a fission reaction, whether it is a fusion reaction, there is always release of energy, and binding energy per nucleon of the outcome of fission or fusion is definitely more than that of the binding energy of the subject. Okay. So this is a very simple problem. So when you have fission, X disintegrates into Y with release of energy. Okay. Now binding energy per nucleon of Y is more. Okay. Similarly, X and X, if they add or they fuse or there is a fusion, then the resultant nuclei is again having a stable nuclei with release of energy. So in both the cases, whether fission or fusion, there is always energy release. Now let us look at the second statement. For heavy nuclei, binding energy per nucleon increases. This is wrong. For heavy nuclei, binding energy decreases per nucleon as Z increases, while for light nuclei it decreases with increasing Z. So this statement is wrong. Statement 1 is correct and statement 2 is wrong. So option D is the correct one. Statement 1 is true and statement 2 is false. Similar kind of problem with two statements. For a mass m kept at the center of a cube of side A, the flux of gravitational field passing through its side is 4 pi gm. Okay. Now let us try to understand. Assuming that we have a Gaussian surface with mass m kept at the center of the sphere, then the gravitational field at each and every point will be radially inward, and by symmetry the magnitude will be same. Okay, and this gravitational field E will be given by Gm upon r square. Now if I wish to find out the total flux of the gravitational field entering this Gaussian surface, I just need to multiply this gravitational field with the total surface area, which is 4 pi r square. So the flux becomes Gm upon r square into 4 pi r square. So this will be equal to 4 pi Gm. Now actually the sign has to be negative because the flux is entering the surface. Okay. Now if I take a sphere which encloses a cube of side A, okay, and the mass is kept at the center. So in this case also the total flux which is entering the sphere will also enter the cube. So the flux of sphere will be equal to flux of cube, provided cube must be enclosed in the sphere. Okay, so with this analogy we can say that the flux associated with the sides of the cube will be also equal to 4 pi gm. So statement 1 is correct. Okay, so statement 1 is correct. Now let us look at the statement 2. If the direction of a field due to a point source is radial, okay, and its dependence on the distance r from the source is given by 1 by r square, its flux through a closed surface depends only on the strength of the source enclosed by the surface and not on the size or shape of the surface. Okay, this is also quite logical. If let us say you have a source here and you assume a sphere, and if the field due to the source is always radially inward, that means it is always pointing towards the source or pointing away from the source, and the intensity is inversely proportional to square of the distance between the two, then the flux that is entering the surface will always be proportional to the strength of this subject. The same analogy we have discussed just now in the case of gravitation, and you must be aware of the same analogy in the case of electrostatic charge. So the statement 2 is also correct, and also the correct explanation of statement 1. So statement 1 and statement 2 both are true, and statement 2 is correct explanation of statement 1 is the correct option.